For this video, we are going to be discussing dependent events. So we've already talked about independent events, and in independent events, the probabilities of one event did not affect the other. Well, dependent events are the exact opposite. Dependent events are when the occurrence of one event changes the probability of the other. For example, drawing two cards from a deck without replacing the first one. Taking the first card out changes the probability for the second card. So if you think about it, for my first card, whatever the card is, my probability is going to be something out of 52. Then I take that card out, and for my second probability, well, I have one less card in there, so my probability is only going to be out of 51. So the probability changes, and that's what makes it a dependent set of events. And a key word to look for is without replacement. Whenever you are taking stuff out without putting it back in, that is going to be a dependent event. So without replacement should cue you in that you're talking about dependent events. So let's take a look at how to figure this out. So to find the probability of two dependent events happening, you're going to find the probability of the first event, find the probability of the second event after the first, and then multiply them together. So let's look at some examples. Example 1 says 22 boys and 28 girls put their names in a drawing to win a prize. 2 winners will be chosen. I want to find the probability that a girl wins the first prize and a boy wins the second. So we're going to find the probability of a girl winning first prize and a boy winning second. Well, let's figure this out. We've got our first prize here. We know we want a girl to win that. Well, there are 28 girls, and there are 50 total names in there. So the probability is 28 out of 50. All right, that reduces to 19 out of 25. Sorry, 14 out of 25. Erase that, make it look a little better. Not 19 out of 25. 14 out of 25. For second prize, we know we want a boy to win. Now, the first person being chosen is a girl, so her name has been taken out of the drawing. So now there are only 49 names to choose from, because you can't win both first and second prize. Once that girl was chosen as a winner, her name gets pulled out of the drawing. That does not change how many boys there are, so it still says 22 over 49. So, to figure this out, we're just going to multiply these two things together. And I am not going to try and do that in my head. So, we know our probability of a boy winning or a girl winning first prize is 14 out of 25. Probability of a boy winning second prize is 22 out of 49. So 14 times 22 is 308. And 25 times 49 is 1,225. We're not going to even try and reduce this. We're just going to say that right there is our answer. 308 over 1,225. All right? And let's see what that is as a decimal. 308 divided by 1,225. Roughly 0.25 or 25%. So, the way we did this, we just found the probability that a girl wins a prize. It's 28 out of 50, which is 14 out of 25. Then we took that girl's name out of the drawing, which reduced our total number of options to 49. There are 22 boys still, so 22 out of 49. Multiplied our two probabilities together to get 308 over 1,225. All right, let's take a look at example 2. Example 2 says, given a shuffled deck of cards, find the probability of drawing 2 kings in a row without replacement. All right. So, we're trying to find the probability of drawing a king and then another king. All right. So, our probability of getting our first king We have 1, 2, 3, 4 kings out of 52 total cards. That reduces to 13 over, sorry, that reduces to 1 over 13. All right, so now we pull out a card and we get our king. So now that card is pulled out of the deck. Because it says it's without replacement, once we've taken that king out, it cannot go back in. So now for my second king, well, now I only have 3 to choose from. And I have 51 total cards because I've taken that away. Notice that both the number of kings and the total number of cards went down by 1 because I took 1 out. So I'm going to multiply now. I get 3 over whatever 13 times 51 is. That is 13 times 51, 663. 663. This reduces. These are both divisible by 3. 3 divided by 3 is 1. 663 divided by 3 is 221. So the probability of getting 2 kings in a row without replacement is 1 over 221. Because my probability changed when I took that king out and did not put it back in. All right, example 3 says a bag of Skittles contains 8 orange, 3 purple, 6 red, 4 green, and 2 yellow. You're eating them one at a time. Find the probability that you first eat an orange and then a green. So let's kind of draw this out. It says there are 8 oranges. 1, 2, 3, 4, 5, 6, 7. 8 oranges. 3 purples. 6 red. 4 green. I guess we're using this neon green. 2, 3, 4 green. And 2 yellows. Hopefully you can see that yellow. It's kind of hard to see. All right. And it says you're eating them one at a time. And you're trying to find the probability that you're going to eat an orange and then a green. So let's find our probability of an orange to start. We know there are 8 oranges out of a total of 11, 17, 21, 23. So 8 out of 23. That doesn't reduce, so we'll leave it like it is. And now we need to find the probability of a green. But it says you're going to first eat the orange and then a green. So when you eat that orange Skittle, now it's gone. Okay, it can't be put back in. That doesn't change the number of greens. There's still 4 of them. But it does change the total number. I got rid of 1, so now this becomes 22. So now 8 times 4, that's 32. 23 times 22. 23 times 22. It's 506. These things are, well, let's see. I don't think this is divisible by 4. Nope. So these are both divisible by 2. That's 16. 506 divided by 2 gives me 253. So my probability is 16 over 253, which is roughly 0.06 or 6%. So all we did is we found our probability of orange. We took 1 away because we were eating that Skittle. Then we found our probability of green. We multiplied them together. So that's all you have to do to find the probability of dependent events. Is find the probability of one, find the probability of the other, and multiply them together. So your try-it problem is that you're given a bag of marbles that contains 12 blue marbles and 7 green marbles. And your job is to find the probability of randomly pulling out a green and then a blue without replacement. So let me kind of help you out. If we think we've got a picture, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blue, and 1, 2, 3, 4, 5, 6, 7 greens. What it says is you're going to take a green and then a blue without replacement. So you're going to find the probability of green, take one green away, find the probability of blue, and multiply them together.